Guys and girls, it's Know It time!
Your lesson today is on 10. Turn off all lights, Ryan. 10 cotangent graphs. Okay. Now, in order for you to understand tan and cotangent, I just got to show you what it is. On your exam, I won't ask you to draw a tan and cotangent graph. I will ask you about basic information about it. So let's grab our TI-83 and let's just draw a rough and just see what it looks like. Okay? So grab your TI-83 and let's work with this. Oh, wrong one. Where's my TI? Here's my TI-83. First thing, again, always double check your mode. Your mode should be in radians. Because we don't work with degrees anymore. That's kid stuff. We're in seniors now. Under Windows, I want you to change X min to 0. X max, we're just going to do 2 pi. Okay, because standard's 2 pi. Y min, we'll change it to maybe -5. Y max, we'll change it to 5. There's a reason I'm using those numbers. I'll show you later. Okay. Y min is -5. Y max is 5. Make sure your scale matches my scale. Okay? And that's all it is, right there. Yep, all 1. So now you go to Windows. Sorry, hit Y equals to right now. And let's clear everything you had in there. Under Y1, just punch in tan. And hit X. And just end bracket. Because I just want to know what a tan graph looks like. And hit graph. Okay. So if you look at tan graph, that's what you should have. So under Y equals, just hit 10x. Because I just want to see your graph should look exactly like my graph up here. No tricks. So the problem is, you see these vertical lines right here. Those are your asymptotes. These vertical lines right here are called your asymptotes. Now normally asymptotes aren't shown on graphs, but in this case they decide to show your asymptotes. So first of all, I want you to take your little arrow key or and move your little cursor to the first asymptote and tell me what x roughly equals to there. Right about there. Yeah, right. My first asymptote is roughly right about there. About 1.5, 1.6 between there. Okay. So I'm going to write a few things down. Tan. So my heading today is tan graphs. Tan X. Okay. We're going to draw a little grid because I'm going to try to replicate this in my drawing. Tan graph is pretty simple. There's very little calculations you got to do. That's why I save it till the end. My first asymptote is roughly 1.5 something according to what you just found. So somewhere to the right, I want you to draw in a little asymptote right here. I use dotted line to show it's an asymptote. Now, the actual number really is pi by 2. So we're going to go pi by 2, label pi by 2. Because pi by 2 is really 1.57. The next one, we can take our little cursor again and move it all the way to the next asymptote. Okay, just take a look all the way. Okay. And my second asymptote right here, 4.67, but really, let's use pi. And I'm going to give you what it is. And this number right here is actually 3 pi by 2. Now, this tan graph keeps on going. It doesn't end. There's another one to the right of 3 pi by 2, which is, I'm going to tell you the number, 5 pi by 2. You can probably predict the next one after that. 7 pi by 2. Okay. So that's your asymptote. These are the numbers you're going to memorize. Burn these numbers in your head. Pi by 2. 3 pi by 2. 5 pi by 2. Okay. So what we're going to do is halfway between pi by 2 and 3 pi by 2, put a little tiny dot, just a tiny dot. Halfway between 3 pi by 2 and 5 pi by 2, put a little tiny dot. And I'm going to draw my graph right now. I'm going to start close to the asymptote. Go all the way down to this dot right here. Touch the dot. Okay. From here, it goes all the way down like that. And it never passes the asymptote. Guys, gals, do the next one on your own. See? Start from the asymptote. See, it's to the right. All the way down to the center dot. I put the center dot just as a marking symbol where it should pass through. And just all the way down. All the way down. Voila. Nothing too bad. Now, some of you say, Mr. Snow, what about this first one right here? Well, there's actually one more. What's the asymptote to the left of pi by 2? That's what you got to think about now. Sorry? Negative pi by 2 is correct. So there's one hidden one right here to the left. And a lot of people are thinking it's 0. It's not 0. It's negative pi by 2. So we're going to draw in one more. Okay, just all the way down, touch it. And this is called a tan graph. And if you compare it, look at this. They're the exact same thing. And that's what a tan graph looks like. Well, I'm telling you what these numbers are. You're going to memorize it for yourself. So these numbers are pi by 2, 3 pi by 2, 5 pi by 2. Key differences, star. This is where students get mixed up. If I look at this one, would you agree that the tan graph repeats itself pretty soon? It's not as sine and cosine anymore. Tan graph repeats very quick. Sine and cosine takes a bit longer. So first of all, looking at this tan graph, I want you to tell me what the period is going to be. Period. And remember, to get your period, we take our end point minus my beginning point, which is 3 pi by 2, that's my ending, minus pi by 2. So the period of a tan graph is pi. This is the first difference. I'm going to write a few things down for you to understand. This differs from sine and cos. Okay. In sine and cos, period is normally 2 pi. Is normally 2 pi. So there's actually a formula for tan period. The period, this is the formula for tan. Tan period equals to pi. We're not using 2 pi anymore. We're using pi over b. I want you to bubble this, please. This is the biggest difference between tan versus a sine, because a lot of students get mixed up. They use 2 pi over b. In a tan graph, the period changes to pi by b. Guys, that is your formula for a period of tan graph. Okay. I remember this because this question was given in my Math 12 exam, and I got this wrong. Maybe you can do better than I did back then, 3 years ago. No, I still remember up to this day because I kicked myself over it. Okay, my teacher was Miss Reed. She was a great teacher in Math 12, and she gave us this question, and she asked what was the period of this formula for this tan 3 theta. Guys, let's get cracking. And I'll give you the choices. Up to this day, I still remember all the choices. It was 2 pi over 3, b pi, c 2 pi, or d pi by 3. 3 years ago, when I was your age.
You picked A, didn't you?
Sorry? I did pick A.
You did?
I did pick A. I remember up to this day, I chose A. Because I say, hey, that's 2 pi over b. But remember, you're working with tan now. When you work with tan, the formula changes. So the actual answer is not A. B? Oh, is wrong also. It's actually D. Because that's all there is. This is called tan. Cotangent, same concept. Okay, tan and cotangent have the exact same formula. Cotangent period. Exact same thing as tan. There's no difference. Pi over b. That's it. Guys, gals, your work for today.
Are you serious?
No, I'm not. You actually fell for it? Here. So that is the period. Now the last thing I'm going to teach you is called asymptotes. How does the B value change? Because the B value would change your asymptote. Your asymptotes. How does the B value change it? And it changes by this. If there's a B value, your asymptotes will change. It's given by this formula. This is actually a unique formula I actually created, and this formula is this: new asymptotes. Asymptote. And it's one of your last few formulas you have to remember. I'm going to use NA equals to old asymptotes over B. I'm going to use OA for old asymptote. Okay. So we're going back to this question. Y equals to 10 3 theta. First of all, you're going to write down your original asymptotes for a tan graph. Those ones I asked you to remember. The first one, Paul, what was the first one that I asked you to remember? Pi by 2. You got to remember these by heart. Okay, these are the ones you got to burn in your head. Gavina, what's the next one? 3 pi by 2. That's correct. Ryan, what's the third one? See, I can go on forever, but I just want to give you the first three. Now, these are the original. But look at this. My equation has a B value. I want you to find the new asymptote for each one. I'm going to pause it and let you. See, to find my new asymptote, I'm going to use a formula just somewhere on the side. I take my old one divided by B value, which becomes pi by 6. So my first one is pi by 6. Second one, I do the exact same concept. There's no tricks to it, which is 3 pi by 6, but really I can rewrite this as pi by 2.
So how many do you have to do it?
Just do about 2 or 3 is fine. Because now, really, the question is how many you have to do it for. There's so many asymptotes that goes on, so they're going to create something called find the equation of your asymptote. Because I can write this forever and keeps on going, so why don't we just come up with a general equation? And this goes back to your what we did last time. So here's the equation. It's your first asymptote. I should say first new asymptote. First NA plus or minus N period. Notice this is different from secant and cosecant. I don't divide the period by 2 anymore, because it's just N period. And you got to go NEI. NEI. Because I can write as many asymptotes as I want, but instead of wasting my time, let's just come up with a formula. So I take my first asymptote, which is pi by 6, plus N. Now my period of this is actually pi by 3. Period equals to pi over 3. So it'll be N pi over 3, comma, NEI. Guys, gals, that's the only thing I will ask you for a tan graph. What is the new asymptote and what is your equation going to be? I will never ask you to graph it. Try this on your own. I'm going to walk around. I'm going to help you out. And we're going to do cotangent, and then we're done. I want you to do the same thing. Y equals to 3, 10, 1/2 theta. I'm going to ask you find, let's just find 2 new asymptotes, 2 NAs, create an equation. I'm going to pause it and let you try this on your own. And after this, we finish tan graph. Cotangent is even easier. So everything really is based on formulas. I only ask you 2 things. What is asymptote And what is your period on the graph when it comes to tan? So find about 2 or 3 new pairs asymptotes. Hey. Oh, I forgot to pause the test. Pause. So I'm going to just use the formula. All these numbers right here, the 3, it doesn't change in any way whatsoever. So I go Na equals to my original asymptote, which is pi by 2 divided by 1/2. Robert, what's my first new asymptote? So pi by 2 divided by 1/2 is 2 pi by 2, which is pi. So my first new asymptote I know is pi. I'm going to do another one. The reason why? I just want to see what the trend is like. 3 pi by 2 divided by 1/2. And would you agree you get 3 pi? See, I can keep going forever, which is 5 pi, but really, I want to just end this nonsense and create a formula. Because once you have your formula, you don't need anything else. So my formula is my first asymptote, which is, so we're going to say x equals to pi plus n period. Now my period is 2 pi. And 2, oh, plus minus, yeah, because you can go backwards. And we write down NEI. Voila. In the book, they sometimes may use 3 pi. Like I said, every word is different. You should be able to figure out where these numbers come from, though. That is called tangent. Easy. One last thing, and we're done this trig part 1.
You have your winners there.
Sorry, what? Oh, winners, what are we talking about winners?
I saw
What?
it said winners with match on.
Oh, I'm so, yeah, I was creating it, but I'm still trying to narrow it down to make it fair for everyone. This is called cotangent x. And this is the last one. Same concept. Here's how you do cotangent. Let's draw a little grid. Again, like I said, I will never ask you to draw these graphs. I only expect you to figure out what the tangent, what is the asymptote, and what is the period going to be. Sorry? For these stuff. So most of the time you probably find this on a multiple choice. So the first one you're going to work with is 0. Draw an asymptote at 0. There's another asymptote. See, tangent and cotangent are very similar to each other in that they're all based on asymptotes. Next one is pi. Yeah. Thank goodness I don't have to. Just you guys. 2 pi. So is every pi away. 3 pi. Cotangent is actually easier because the numbers are easier to memorize. Halfway again, I want you to put a dot right smack in the middle. Dots. Dots. Dot. Now, normally you would follow the same trend as tan, but this time it's worked the opposite way. Start really close to the left this time. All the way to left, and go all the way down to the middle. Touch. And go right through. It goes the other way. See, cotangent just differs on the asymptote, on your original asymptote. So what I want you to remember for cotangent is 0, pi, 2 pi, and 3 pi. Guys, continue on and finish this off. Just same thing, nothing too bad. Keep it simple. Same thing, nothing too bad. Keep it simple. And what you have is cotangent graph. What I expect you to remember from this is same concept, period, equals to pi over b. Same formula as tan. Your original asymptote, you got to remember, it changed from tan. Now it's going to be at 0. Pi, 2 pi, 3 pi, dot, 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 dot. These are your original ones. New asymptote, same formula. OA over B. Exact same thing. I'm going to give you a question. You're going to figure this one out. Y equals to negative 4 cotangent to theta. they're going to ask you if you could find the equation of the asymptote. Follow the same guideline as you did with tan. Only difference now is your OA. My original asymptote differs from tan. The rest is exact same concept.
Isn't 0 divided by anything still 0?
0 divided by anything is 0, 0. Yep. So guys, I'm going to pause it. Before I start, I'll always like to find my NA. Okay, I always want to work with my new asymptote because there's a B value. And I'm going to use that formula. I go 0 divided by 2. My first new asymptote is 0. Second new asymptote, I take pi divided by 2, which is pi by 2. Now I can go on to the third and the fourth, but there's no point. From here, go ahead and create your formula. So I take my first asymptote, which is 0. The book may use pi by 2 as the first one. Everything is different. Plus, minus, n. Now I find the period. Nisha, what's the period of this? Pi by 2, comma, n, e, I. Guys, gals, voila. That's all there is to it. This is a lot easier than secant and cosecant, because secant and cosecant is period divided by 2. Remember that. There's a huge difference. Your super note question for today. Good luck. One card to anyone who can get this. I'm going to change things a bit. I'm going to go back and I'm going to test you on this question. Uranium. Okay. Decays to 20% in 6 hours. Find the half-life. Good luck. Because just because we finished the previous chapter doesn't mean you can forget anything. So, if you're lost, this is equal to 20 equals to 100.56 over n. If you did this correct, you should n equals to 2.58, I believe. So, which is 0.2. 6 over n. Guys, gals, remember, log both sides and you get your answer. Voila. Remember, log, because there's a midterm coming up soon, in about a month. So you got to gear up for this stuff. A midterm will test you on 4 chapters. But for now, that's it. Your work. I would advise you to start your review long time ago if you haven't done so. And in addition, Page 72. This time you can do all the questions I didn't sign before. All. Last time I only asked you to work with secant and cosecant. Go back and do tangent and cotangent now on page 72. There's a quiz tomorrow on tangent and cotangent only. Okay? And that's it. Page 72, all, and I advise you start your review. Give me 1 second. Now, what else is there? Exam is on Wednesday. Test Wednesday. Today after school, as you know, there's a strike thing going on.